Welcome to this lesson on empirical formulas. An empirical formula is one of the most fundamental concepts in chemistry. It represents the simplest ratio of elements in a compound. Understanding this concept is essential for analyzing chemical compositions and solving stoichiometry problems. Let's dive in and explore what makes empirical formulas so important. An empirical formula shows the simplest whole number ratio of atoms of each element in a compound. Unlike other types of formulas, it doesn't tell us the actual number of atoms present. Instead, it gives us the most reduced form of the ratio between elements. Think of it as the simplest way to express the relationship between the elements in a compound. Let's look at glucose to understand the difference between molecular and empirical formulas. The molecular formula of glucose is C₆H₁₂O₆. This tells us there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. However, the empirical formula is CH₂O. Notice how we've simplified the ratio. All 3 subscripts in the molecular formula can be divided by 6, giving us the simplest ratio of 1:2:1. Finding an empirical formula follows a systematic 4-step process. First, convert the percentages or masses of each element to moles using their molar masses. Second, divide all mole values by the smallest mole value to get a ratio. Third, if needed, multiply all values by a common factor to obtain whole numbers. Finally, write the formula using these whole numbers as subscripts. Let's apply these steps to a real problem. Here's a practice problem. A compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. Our goal is to find the empirical formula. We have the percentage composition of 3 elements: carbon at 40%, hydrogen at 6.7%, and oxygen at 53.3%. Now let's work through the steps to find the answer. Step 1 is converting mass to moles. We assume we have 100 grams of the compound, so the percentages become grams. For carbon, 40 grams divided by 12 grams per mole gives us 3.33 moles. For hydrogen, 6.7 grams divided by 1 gram per mole gives us 6.7 moles. For oxygen, 53.3 grams divided by 16 grams per mole gives us 3.33 moles. Now we have our mole values. Step 2 is dividing by the smallest mole value. The smallest value here is 3.33 moles. For carbon, 3.33 divided by 3.33 equals 1. For hydrogen, 6.7 divided by 3.33 equals approximately 2. For oxygen, 3.33 divided by 3.33 equals 1. These are already whole numbers, so we don't need to multiply further. Here's our final answer. The ratio of carbon to hydrogen to oxygen is 1:2:1. Therefore, the empirical formula is CH₂O. This formula represents the simplest whole number ratio of elements in our compound. Notice how we've successfully reduced the composition data to its most basic form. This is the power of empirical formulas in chemistry.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.